Hi, this is a demonstration of the Lupin network probe. This is a ICMP-based network probe that goes out and tests the bandwidth or available bandwidth between two endpoints and the latency, round-trip latency between those. And those are very useful numbers for performance evaluations to know, what is the capabilities of people in certain geographic locations. So to start with this, we need a pingable endpoint. So this might be a device, maybe someone's machine, could even be a router. Lots of times a router is a good endpoint, but sometimes hard to find one that you're interested in. A good trick here is to use something like traceroute to see what routers things pass through and find one close to the endpoint that you're interested in. So in this case, I'm going to test between my location, I'm in the US at the moment, and a location in New Zealand, so we should see some reasonable high latency and not huge bandwidth, because there are some bandwidth restrictions going that far. This will use ICMP going to this particular host name, but I could also put in an IP address. The other things we want to use is set the ICMP maximum packet size. Bandwidth is calculated by seeing a variety of different packet sizes and seeing what the difference in time to get it onto the wire and off the wire is. Setting this number higher will give you a more accurate theoretical result, but in a lot of cases you'll find that endpoints only support sort of the maximum single packet size. So 1470 is a good default number to use here, but you see you've got selections for actually a smaller one if you're having trouble with getting pings back at 1470, and larger ones which will give you more accurate results, especially for higher bandwidth. So if you're using this inside an enterprise and say you've got a 100 meg network, it may be good to find an endpoint that responds to these much larger ICMP packet sizes. So I'm going to use 1470 here for this demonstration. Also, how often you want to run the tests. These tests will run continuously once you start them. So I'm going to, because this is just a real-time test here, I'm going to run them every 5 seconds so we can see change over time. In many cases, when you're doing the performance evaluation, you want to measure what's the available bandwidth and latency over time, much longer time, say over a day or over a week, so you can see what the variation is, say during the business day or during the week, as compared to say weekends or holidays or something like that. But for this test I'm going to use every 5 seconds, but you can see you've got various options there. The other thing is where you want to put the output from these tests. By default it'll put them into your personal documents folder, and it'll give it the name of the endpoint address that you specified up the top as the file name. It's going to be a tab file or a tab delimited file, which makes it easy to import into something like Excel. I've actually set this up to output into my temporary directory into a folder called probe output. I can change that by selecting the change button and running down through and selecting the directory, but I don't want to change this. That should be all set up, ready to go, so I'm going to press the start button. It's going to start testing straight away. So you see the first test here is shown down in the status bar. It's seeing just over 1 meg of available bandwidth and 200 milliseconds or 212 milliseconds of round trip time. Because I've set it up to test every 5 seconds, you see these numbers change approximately every 5 seconds. The other interesting thing is the theoretical accuracy of this. So depending on the packet size and the bandwidth that measured, that theoretical accuracy can change. At the moment with this packet size and this sort of range of bandwidth, I'm seeing about an 8%, plus or minus 8% accuracy. You see as the number's higher, then the accuracy decreases. There can be quite a bit of variations in bandwidth because this is testing available bandwidth. If someone's transferring a large amount of data over here, or there's something happening on the network at this time that decreases the available bandwidth, they'll be reflected in the number plotted here. So that's why it's good to get a fairly large sample set so you can see what the true variation is. A lot of times you want to build the performance of the application to handle, worst case bandwidth and latency for your communities of interest. We should have some results here, so simple way to see the results we've gathered so far is just hit the graph button, and there's two lines there, one showing the latency, and you see the latency is fairly consistent here. The blue line here around 200 and maybe 210, 220 milliseconds. That's kind of what I'd expect for this from the US to New Zealand. That's round trip latency, and the other thing is it's showing the plot of the available bandwidth, and you see there's quite a bit of variation here, but I'd say kind of the standard maximum is around 4 megabits per second. And I might say sort of in this range here, 2 to 4 megabits per second is what I'd calculate for being the capabilities for this link. I'm going to stop this. The other way to look at the output is to actually go in and use Excel to graph the results. So I'm going to start up a instance of Excel. I'm going to open up a file there. So like I said, I saved it in my temp directory. So I go to temp, and I saved it in a probe output directory. I'm going to select all files, and you see one here, a tab file, which is for that particular endpoint. I'll select it. It brings up Excel's data input wizard. We can just next through this because it does a good job with tab files. One thing I may want to do, and just in the display of the data here, is change it to a time and get it down to the second resolutions, so I can see each test every 5 seconds resolution. And the sort of thing you can do in Excel is you can select data and use some of its inbuilt charting to do things like make a quick chart of the data you just captured through the probe.